Hello learners, welcome to our session today. I am your instructor CPA Aringo Fredrick, a continuation of what you are doing earlier on in what you normally tend to do best under financial management. And in that case, we will today introduce the second technique, which is discounting technique under the time value of money. Remember, in our last sessions, we've been looking at compounding techniques. So in our today's class, my good student, I want us to introduce a very important part of it, and that should be the concept to do with talk about discounting techniques. So allow me to erase here, and I want us to look at discounting techniques. I want us to talk about discounting techniques. Discounting technique. So we are looking at discounting technique being our session of today. So discounting techniques. This is discounting techniques. We are looking at discounting techniques. Discounting techniques. Discounting techniques. Discounting techniques. That is what I want us to look at today. Discounting techniques. So anytime we'll be talking about discounting techniques, my good students, what should always click at the back of our mind? Discounting techniques refers to the determination of the equivalent present value of future cash flows. We are saying that at this point, it will be upon us to determine the equivalent present value. It will be upon us, this is just determination of equivalent future value of equivalent future value of equivalent future value of equivalent future value of equivalent determination of equivalent present value. First of all, determination of equivalent present value determination of equivalent present value of future cash flows of future cash flows of future cash flows of future cash flows. Basically, it's just the difference with of the compounding technique, where in compounding we were determining the equivalent of the future value of our present cash flows. In compounding, we are determining the future value, the equivalent of future value in our present cash flows. But discounting, it will be upon us to determine the equivalent of the present value of future cash flows, the equivalent of the present value of future cash flows. So in doing this, my good students, ideally, we'll be looking at various components of discounting techniques, and these are the methods under discounting techniques, or term it as the concepts. We normally term them as the components of discounting, the components or term types or methods that you're going to consider, anytime you're looking at discounting technique. Number one method that you must always ring at the back of our mind is just like what we did with compounding technique, the aspect of the present value of a lump sum amount, right? At lump sum, so we are talking about present value of lump sum, present value of lump sum, present value of lump sum. Number two or B, we'll be talking about the present value of an annuity, present value of an annuity, present value of an annuity, present value of an annuity. And in this case, we are going to introduce the one which we didn't look at in our last class. This is a present value. This is a present value of annuity, of an annuity to infinity, commonly known as what? Perpetuity. Commonly known as perpetuity. These terms should not scare us. We're going to understand this concept very well. So we are looking at the components of discounting techniques. And these components of discounting techniques, we are saying we normally tend to talk of three main. That is the present value of lump sum, present value of an annuity, and present value of an annuity to infinity. In this case, we are talking of it perpetuity, to the point that we can't estimate, or rather we can't determine. So let us break down the first component, present value of lump sum. Present value of lump sum. That is what you are going to start with. Present value of lump sum, present value of lump sum. So we are introducing the first one. We are introducing number one, the present value of lump sum. We are introducing number one, present value of lump sum. Present value of lump sum. Present value of lump sum. So looking at present value of lump sum, my good students, you'll find that again is a very simple concept. Because when we'll be looking at a present value of lump sum, what should always click at the back of our mind? It will be upon us, first of all, to understand that at this point, lump sum is, whenever we're talking about it as the concept of lump sum, we just be looking at a case whereby it is a receipt or payment of a fixed amount only once. We are talking of it as this is a receipt or payment of a fixed amount only once. Either it can be either at the end of the period, or at the beginning, or at the beginning, or at the beginning of the period, That is one concept under present value. I am kind of receiving this amount, a fixed amount, only once. In that, napokea mara moja, or you are paying at once. The other concept to do with the present value also we should have in mind is, we are talking about, it may also refers to payment of irregular cash flows. Payment of irregular cash flows at a fixed intervals. Or looking at it also on the third perspective of discounting, or rather of our present value, we can also talk about aspect of these are in calculating. We normally tend to say that maybe that one you can also put it down. It will assist us very much in calculating the present value for lump sum. We normally tend to consider this formula. Recall the formula that you are looking at under compounding for lump sum. Remember the formula that you are looking at under compounding for lump sum. So the same formula we are going to consider here. So at this time we are going to kind of look at it today. It's not like we are going to look at it in future. Meaning that at this point I'll be looking at compounding formula at our present value terms. So to determine our present value interest factor, we'll be talking of this formula of ours. The same formula we are going to look at it, whereby at this point I am going to talk of, we normally tend to talk of this case. Of course, that should be the aspect to do with, if you can recall the compounding formula, my good students. If you can recall the compounding formula, where we normally tend to talk of, I'll just use that same concept so that you grasp it very clearly. Compounding formula, where we are mentioning that for us to determine our amount, we normally tend to consider the principal, right? We multiply by 1 plus r, in that case raised to power what? Raised to power n. That is what we normally tend to talk about, right? Where in this case, we are going to have it in this case, we are going to consider it in this case. This is the compounding formula, that is to determine our amount. Where in this case, we'll be looking at it, we'll be talking about to determine our present value. Interest factor, first of all, interest factor. We will be talking of course, 1 plus r. This time I'm going to have negative n. We are going to consider negative n, number of period. We are looking at it today. 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 So therefore, that is what you should be having. 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 That is present value. We are going to talk of 1 plus r. We divide by n. Of course, in this case, that is to give us our factor. That is to give us our factor. That is to give us our factor. Meaning that if we were to talk of our present value, therefore, at this point, it as if we'll be talking of the future value. We multiply 1 plus r raised to the power negative n. So that should give us our formula at that point. That should give us our formula at that point, because we are looking at, we want to determine the equivalent of present value of our cash flows, equivalent of a determination of equivalent of present value of future cash flows. So to determine our present value, if I'm talking of a lump sum amount, this should always be our formula. We are going to have a factor, which is a future value, the amount that we wish to determine. If it is either regular or irregular, we multiply by 1 plus r raised to power negative n. Say, for example, maybe consider this formula of ours, or rather consider this question of ours. Determine, or rather an amount of 2 million is expected after 12 years. So in this case, this is a question for you guys to understand it clearly. Let us have this illustration question down. Illustration question that will enable us to understand this concept that Mwalimu is saying. At this point, you are told that calculate the amount to be invested today. Calculate the amount to be invested today, the amount to be invested today. Calculate the amount to be invested today. I hope that is still okay. Calculate the amount to be invested today. Calculate the amount to be invested. Calculate the amount to be invested today. Calculate the amount to be invested today. If 2 million is expected, 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 if 2 million is expected after 12 years, 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 at an interest rate, at an interest rate of 8% per annum, at an interest rate of 8% per annum. Calculate the amount to be invested today. If we are expecting 2 million after 12 years at an interest rate of 8% per annum, at an interest rate of 8% per annum. Recall, when we mentioned discounting technique, we want to determine determination of equivalent present value of future cash flows, determination of the present value of future cash flows. That is what we termed it as discounting technique. So we want to determine, my good student, The amount that if we invest today will give us 2 million after 12 years at an interest rate of 8%. That is what we are looking at. The amount that I should invest today that will give us 2 million at the end of 12 years at an interest rate of 8% per annum. So this is how we are going to do. We need to determine our present value. We have the figure here, which is 2 million. We are going to multiply by 1 plus 0.088%, raised power negative 12, raised power negative 12. So, my good student, that should give us how much? That should give us how much? So, at this point, you are looking at it in this case. We will be talking of first of all, let me work 1 plus 1.08 raised power negative 12. That should give us 0.3971, at least 4 decimal place, times 2 million. So we are talking of the amount that we should invest today. We should be talking of how much? So my present value that I should invest today should give us 794,228. So if I was to earn 2 million after 12 years at an interest rate of 8% per annum, I should invest 794,000 today. I should invest 794,228. 228. And this is what we should be having. This is now our present value. That is now our present value. As simple as that. That is now our present value. Where in this case we are looking at it in form of what? We are looking at it in form of talk of it as we're looking at it on a lump sum basis, whereby we are kind of receiving this amount at once. We want to receive this amount at once. And what about in the event that I'm given irregular cash flows, my good students, at a fixed intervals? Where, because remember we've said that also at lump sum, we can talk of payments of irregular cash flows at a fixed intervals. So, if I'm given irregular cash flows, what are we going to do? So this is what we are going to do. Allow me to erase here so that I should kind of bring that concept clearly. We're looking at a case whereby I'm having irregular cash flows, my good students. We are having irregular cash flows, whereby you can be told, consider the following cash flows. That's a question that you're having. My good student, whereby you are told, consider the following cash flows, or rather calculate the present value of the following cash flows components. Calculate the present value of the following cash flows. Calculate the present value of the following cash flows for 5 years. Calculate the present value of the following cash flows. Actually, this was for 4 years. Calculate the present value. Calculate the present value. Calculate the present value of the following cash flows for 4 years. Received for 4 years. So in this case, for 4 years, at an interest rate of 10% per annum. Calculate the present value of the following cash flows for 4 years at an interest rate of 10% per annum, at an interest rate of 10% per annum. So in this case, you're given year 1, 1, 2, 3, 4. Cash flows, these are irregular. I'm given irregular cash flows where we are talking about 50,000, 40,000, 30,000, talk about 25,000. Interest rate, remember the present value factor at this point I was given what rate? 10%. I was given a rate of 10%, right? I was given 10%. So present value, I'm given 10%. I'm given 10%. So we need to determine this amount, my good student. We need to determine this amount. What will we be having? What will we be having? This will be simple. Because to determine this factor, to determine our factor at this point, we are going to talk of this. I'm going to talk of for each year, right? For each year, for each year. So at this point, we are going to take our calculator. We have 1 plus 0.10 raised to power negative 1, because we are looking at the first year. That should give us 0.9091. We're looking at it in this case. Our factor, I've taken 1 plus 0.1, which was our rate. We raise it to power negative 1, right? To give us this factor. The same case, I can do it for the second year. Now for the second year, it will just be simple. We just divide by 0.1. We just divide by, we just kind of, in this case, we multiply by 0.1. So talk of 0.9091, 0.9091 times 0.1. We can do that. Or alternatively, first of all, let us determine the second one first of all, so that we should not mix it at first. The second period will come and have 1 plus 0.1 raised to power negative 2. We're looking at the second year, right? So I'm having 1.1 raised to power negative 2. Raised to power negative 2. So I'm having 0.8264, believing that we're getting the same things, right? Believing that we're getting the same things. Then the third one, we're going to talk of the same case. We are going to talk of talk of 1.1 raised to power negative 3 this time around, right? So that should give us 0.7513. The last one, you should be talking of 1.1 raised to power negative 4. So that should give us a figure of 0.6830, correct? So after we do have that case, my good student, what will we be having as our discounts? Talk about our discounts now. So the discounts that I should be having, I should be talking of 50,000 times 0.9091. I should be having 455. 40,000 by 0.8264. 33,056, believing that we're getting the same things. 30,000 by 0.7513. 22,539. And the last one, 25,000, we multiply by 0.6830. That should give us 17,075. So therefore, as at the end of the period, we should be talking of plus 22,539 plus 33,056 plus 45,455. So that should give us a figure of 118,125,000 as at the end of the 4 years. As at the end of the 4 years. So basically, at that point, we have talked of irregular cash flows. We are looking at our 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 irregular cash flows. So that is what you should be having, my good students. Anytime you are talking about what? Anytime you are talking about that concept. The next part I want us to talk about, in this event, maybe we are kind of receiving this semi-annually, say for example. We are receiving semi-annually, not yearly. Assuming that in this case you are told that calculate the amount of to be invested today, 12 million, is expected after 12 years at an interest rate of 8%. At an interest rate of 8%, paid semi-annually. Paid semi-annually, paid semi-annually, paid semi-annually. Calculate the present value of 100,000 shillings expected, or rather of calculate the present, calculate the amount to be invested today if 2 million is expected after 12 years at an interest rate of 8%. So, in our next class, we are going to talk of, in the event that probably I am given interest which is paid semi-annually, what will you be expected to do? So to that juncture, I want you guys to meet me in the next session whereby you're going to talk about that. Thank you so much, and let us meet in the next session. Thank you.